Welcome to Fields of Change, an audio video series brought to you by the Foundation for Agrarian Studies. In the lead up to the FAS International Conference on Agrarian Change to be held from November 6 to 9, 2025 in Trivandrum, Kerala, India, we bring you conversations with leading scholars on major themes around agrarian change, including land and labor, rural living standards, science and technology in agriculture, and the impact of climate change. Part 3A explores how modern science and technology is transforming agriculture and its impact, particularly in developing countries like India, as discussed by Professor R. Ramakumar. Science and technology have long shaped the course of agriculture. What have been some of the key milestones that have transformed agriculture and food production as we know them today?
That's a very long answer to a short question. The whole story of interplay between science, technology, and agriculture is probably one of the most transformative stories ever recorded in human history. Uh, in my view, there would be at least 4 or 5 stages through which this evolution has taken place. The first stage would be what people or historians would call as the first agricultural revolution, which happened at about 10,000 BC or so. That's the time when plants and animals were domesticated by the humans, and there was a shift from the original hunter-gatherer societies to a system of settled farming. That was the first stage of this revolution that we are talking about. This was not a high technology revolution. This was a very primitive revolution, so to say. It was an application, nevertheless, of knowledge. They selected from the wild plants the best that they could choose, the best animals they could choose for human use. So the outcome was permanent settlements and some kind of a stability in food supply. This was followed by the 18th and 19th centuries. Following the Industrial Revolution, you had mechanization, which came in a big way. These machines replaced human labor, animal labor, and they allowed human beings to expand the scale of cultivation enormously, which also led to increases in efficiency and productivity in farming. So, for example, it was in this period that the seed drill by Jethro Tull, or the cotton gin or the reaper, all these things were developed during this time. So scale came up as a result, leading to increases in productivity and efficiency. Then came the sort of a mid 19th century to the 20th century period, which I would call as the input revolution period. This was the time when synthetic fertilizers came to be applied. Earlier, this was not possible because the Haber-Bosch process, which came up during this time, which created ammonia from atmospheric nitrogen. This allowed for the mass production of synthetic fertilizers, which was, in my view, a watershed moment in this whole transformation of agriculture from the first Neolithic period itself. This was also the time that pesticides and herbicides came to be used. DDT, 2,4-D, all these chemicals came up, which allowed farmers to control pests, weeds, etc., which were causing enormous amounts of crop losses in the past. In the 20th century happens the fourth kind of a revolution, which in some sense is the genetic revolution, as we would call it. This is equally important as the scientific input revolution of the earlier century. Here, plant breeding developed in a major way. Breeders like Norman Borlaug or our own M.S. Swaminathan in India, they developed high-yielding, disease-resistant, dwarf, photo-insensitive varieties, primarily of rice and wheat, but later more other crops as well. These could support heavy heads of grain without lodging, as they would call it, and they were also highly responsive to the use of irrigation or use of chemicals like fertilizers and so on. As a result, you saw an extraordinary rise in productivity of these food crops. This happened in the developing world largely. For the first time, global food production outpaced the global population growth rate during this time. In fact, Emma Swaminathan was once to say that in 10,000 years, India produced only 50 million tons of food grains, but in just 25 years, India could double it to 75 million tons of food grain production. So that is the fourth stage. We currently live in the fifth and final stage, an ongoing stage, which is more of a biotechnological revolution, so to say, which is, of course, genetics is part of biotechnology, but this is a little more advanced than what happened during the Green Revolution period. Today, you have genetically engineered crops, which are GMOs, where you can directly insert genes into crops, which creates certain traits in these crops, which help them to resist the attacks of pests and diseases or increase productivity and so on and so forth. You also have digital technologies in use today, like precision agriculture, agriculture conducted with satellite guidance, the guidance of drones, sensors, etc., which allow farmers to manage their farm very minutely, very precisely, even from a remote location. Right. So this allows farmers to increase the efficiency of input use, particularly water, fertilizers, etc., through drip irrigation, fertigation via these micro irrigation techniques, and so on. So these are essentially 4 or 5 stages through which science and technology has developed. And the most fundamental point about the last two revolutions is that humankind was able to increase production of food for its activities, for its necessities, without cutting down forests anymore, without increasing the area under cultivation. So from unit area, when you increase production, it means that you do not have to cut down forests for cultivation, which used to be the case in the past, which was hugely responsible for emitting carbon into the atmosphere, for example. So this last two stages that we are talking about are also enormously friendly to the environment. They are carbon saving in a big way, which is an additional feature of these new technologies, in addition to the trait of increasing productivity that we mentioned. So we are living through a period, we are living through at least 4 or 5 periods of great breakthroughs, which created waves of innovations. Today, we see further advances like gene editing. The CRISPR technology, for example, has come in now. You now have new ways of urban agriculture, which allows you to do vertical farming. All these possibilities are today available thanks to these breakthroughs, and these have made an enormous difference to how human beings live today in today's world.
There's increasing concern today about private control over agricultural innovations, like patents on seeds and other technologies owned by big corporations. What does this mean for small farmers and for developing countries?
No, that's a very important question, but also a very complex question, allow me to say, because this shift from public funded, more open source kind of agricultural science of the Green Revolution time in the 1960s and 1970s to the more privately driven, patented, protected by proprietary rights or royalties, technologies, is a very major shift that has happened between the fourth revolution that I mentioned a while back and the fifth revolution. The fundamental difference between the fourth and the fifth revolutions that I mentioned is that the fourth one was largely publicly funded, but the fifth one is largely privately driven. And that has created new contentious issues in how the narratives or policies on agriculture have evolved. Those who support this kind of a privately funded technological progress, they would argue that proprietary rights are required or patents would be required for new innovations to come. They create incentives for innovation. They create accesses to new technologies. They create new high quality, high tech products thanks to these heavy R&D investments which are made by these private corporations and so on. There is an element of truth in that argument. However, it is equally important to note that there are major negative impacts as well of these changes that we are talking about, particularly in India, in a country like India. When you look at the changes that have been wrought by the private agricultural research, you see that private agricultural research is limited to certain crops where the private sector is able to make a profit. For example, if there are crops where varieties are more suited than hybrids, the private sector will not be interested in that crop or research in that crop because they will not be able to sell seeds every year, because farmers can then save and use the seeds. Similarly, in some crops where high amount of profits are not possible, you will not see the private sector coming in. So the choice of which crop to research into, the choice of where to create an innovation is not anymore decided by a societal need or the national need, but by the needs of profits. Whether there is profit or not becomes the guiding principle of where private investment will flow. And now that creates a very important second problem, which is that this technology sometimes becomes expensive. When technologies become expensive, even when they lead to an increase in productivity on the other side, the high cost of cultivation can create a high risk situation for the farmer, particularly in the possibility, given the possibilities of crop failures and so on and so forth. This will lead to increased costs of cultivation for the farmer, and in acute situations can lead to new debt burdens and so on. So that is one part of the story which is very important. The second part of the story is that even if it may be appropriate for the farmer to buy a new seed and sow it, scientifically appropriate even then, it is important to preserve the freedom of the farmer to save and sow his or her own seed. That sovereignty is to be preserved for every farmer. Even in the case of modern agriculture. But if farmers are in some sense dependent on the private corporations for every seed that they have to use, then there is an additional problem of loss of autonomy and loss of sovereignty in this whole process that we are talking about. Then there are problems of the concerns, at least, of reduced biodiversity and so on, or increased possibilities of resistance to pests and diseases, etc., when the private sector chooses technologies or routes of progress primarily dependent on where the profits are. For example, the BT cotton technology that has enormously progressed in India. Agricultural scientists are of the view that BT varieties are more appropriate in rain-fed conditions of India, whereas the private sector is increasingly interested not in BT varieties, but BT hybrids, which means that farmers, on the one hand, lose their ability to save and sow seeds, but on the other hand, they are also burdened by high costs. There is also the risk of monocropping and so on that might result in reduced biodiversity. So this kind of tension is there, which can be resolved only through a strong public agricultural research system, particularly in the developing countries, which will not stifle local autonomy or local sovereignty. It will ensure that the variety or the crop chosen has a societal benefit coming out of it and not just a private benefit. And it also allows costs to be kept low, because public sector can sell many of these inputs at a lower cost. Right. So what we see, however, on the other hand, today is a sort of unleashing of the power of private monopolies in the field of agricultural research. They do bring about new technologies They do bring about innovations and so on, but questions remain as to how accessible are these technologies, how socially useful are these technologies, and how do they contribute to the major objectives of food security and so on. So this concentration of power, concentration of market power in seed industry, in fertilizer industry, in pesticide industry, in herbicide industry, and not to talk about marketing, logistics, and so on the other side, is one of the most important problems that we face today with the coming in of private corporations, largely multinational corporations in the field of agricultural research.